Good afternoon or good morning to those who may be joining from the West Coast. My name is Cameron Kilton. I'm Director of Engineering Services here at Baicells, primarily focused on the pre-sale efforts as well as the post-sale support and things of that nature. I'm going to talk about today a few different things wrapped around the concept of LTE. If you haven't been using LTE, why maybe you should start considering to do so, and some of the benefits it does have over traditional fixed wireless applications. A little bit of background on myself. I've actually been a part of two different fixed wireless operators, one that was focused on Wi-Fi based chips and one that was essentially all LTE. So I've kind of lived in this space for an awful long time, since the late 90s for that matter. So chances are, if you've thought about it or working on it, I've done it. Certainly happy to take some questions afterwards and get some opinions of your particular deployment and some scenarios that may be pertinent to you. If you have any questions, do put them in the chat box and they'll get sent over to me, and I'll try to address those as we go through the presentation. And by all means, don't feel like you have to wait to the end to ask a question. If it's pertinent to the slide at the moment, feel free to ask. With that said, we'll get started. So we'll go over, like I mentioned, LTE basics, why LTE, why Baicells naturally, how LTE solves some non-line of sight challenges. We'll talk a little bit about CBRS update towards the end, and we'll do a brief Q&A. LTE, I'm not going to read these verbatim, but long-term evolution has been around for an awful long time. A lot of people remember the first parts of LTE commercials was kind of thanks to Verizon's "Can You Hear Me Now" guy. That's really where the revolution kind of started to happen, and moving to more bits per hertz, some more non-line of sight coverage, and certainly higher capacity compared to that of the 3G networks, and still some networks that run across the country here at both 1G and 2G speeds. Main goals and benefits of LTE: we can do full duplex or FDD and half duplex TDD in the same system platform, seamless connection on legacy systems, higher throughput, lower latency within reason, and certain superior end user experience in regards to signaling. And we'll talk a little bit about that a little bit later on. LTE network architecture has three main components, and of course that is very simplistic of LTE. There's a lot more that kind of happens behind the scenes, but it's broken down to user equipment, otherwise known as UE. And that kind of replaces the old adage of the CP, or the customer prem equipment, because in the LTE handset world, they're not traditionally fixed, they're mobile. So LCPE for customer prem doesn't fit that criteria, so they decided to come up with a new acronym and just call it user equipment, which essentially encompasses all of it, both fixed and mobile. Then you have the terrestrial radio access network, or evolved UMTS terrestrial radio access network, also known as the EU-TRAN. At least that's how I pronounce about it. What you'll hear a lot in the fixed wireless space is you'll hear BTS, base station, access point. What they all really mean in an LTE sense is eNode B, otherwise known as the ENB. You'll also hear the term EPC an awful lot, particularly if you're just coming into LTE and you start talking to some LTE veterans. You're going to hear the term, do you have your own EPC? Are you doing distributed EPC? What that really means is evolved packet core. Long of it short, it's essentially the collection point before data actually happens that encompasses all the traffic. And it encompasses both what they call an MME, a S gateway or serving gateway, and a P gateway, also known as the packet gateway. This is kind of more of the signaling happenings and how it works from a user equipment side, or CPE, all the way through back to the internet. So this guide here is kind of how the whole system takes place, and we even have some other references in here to, like, seamless handoff in the LTE space and how that works. You'll see from left to right, we'll go into UE to an eNode B. So this is one of your base stations on a given tower. Or we'll say, for example, in this case, this one's sitting between two base stations, and we use what we call X2 protocol to talk between the two base stations, and they will determine what's the best sector that you should be attaching to. Very handy feature, mobility centric in that sense, and helps avoid some other various issues such as ping-ponging, which is essentially a situation where you have a subscriber bouncing between two sectors constantly, causing some unwanted experience for the user. With that said, the S1 MME happens between the E node B and MME. That's essentially a secure connection between your base station and the EPC. And that flows into the HSS and the serving gateway. The HSS essentially is a fancy way of saying that's what holds all the SIM card information, and that's what does the authentication mechanism. So it's a fancy way of saying, hey, I'm a radius server for LTE. It's a little oversimplistic explanation of it, but that's a good way to kind of wrap your head around what an HSS is. That particular functionality goes back and authenticates the subscriber and starts sending the traffic through the serving gateway and the packet gateway. And eventually you go with, they see this little SGI on the right, which is the interface that then talks to the internet. This is our CloudCore design. So for those who are not familiar with Baicells, which I suspect there's probably a few on this call, is we, in order to lower the cost of entry to LTE, there's usually a significant expense in buying an EPC, the Evolved Packet Core. These range anywhere from lower end EPCs that are several $1,000s to very high end EPCs that are in the millions, plus annual service subscriptions for maintenance and all that for those EPCs. So they get very, very expensive. So one thing that Baicells done is we were able to put the EPC up in the cloud, and this is kind of the architecture of what it does from a redundancy standpoint and a provisioning standpoint. This allows us to lower the cost of entry. That saves you from having to go out and buy an EPC. We do this thing called local offload, which is also known as, we call it local gateway, where we actually have two parts of the traffic, those S1C and S1U. So we send the control information over the IPsec tunnel, over AIPsec tunnel rather, to our cloud EPC that does all the authentication mechanisms that you have complete access to, you control. You have an API that you can tie in with your billing system, etc. Then we have S1U, the user traffic gets handed off locally to go right straight to the internet. So there's no need to backhaul the internet, obviously, to a cloud. That'd be very inefficient. So that is a very unique thing that we do here at Baicells that allows a lower cost of entry into LTE and gives you more control of your network locally. So you can actually have multiple different uplink providers. Say you have kind of a your regular centralized network, then you want to start another network elsewhere. It's a different uplink provider. There's nothing preventing you from do that. You still have a centralized provisioning system in the cloud EPC that does all of that, regardless if you had, say, Charter or you had Time Warner at different locations for backhaul. It's still a centralized provisioning system, regardless of uplink, which is very handy. The key features of LTE, you'll hear me use that term a lot. There's a lot of really neat things about LTE, ones that you get advantages over compared to other Wi-Fi based chipsets by comparison. Channel sizings are pretty standard. Most equipment that you'll play with from Baicells is going to be TDD, potentially to CBRS or band 41. Common channel supports are 5, 10, 15, and 20 megahertz support. And you get into the FDD, the full duplex systems, there'll be 1.4 megahertz channels, 3 megahertz channels, but for the most part, it lives in the 5, 10, 15, 20 megahertz space. Different modulation schemes, we go up to 64 QAM currently. However, we have a product that we're working on that goes as much as 256 QAM. That obviously allows for a lot more throughput. And by comparison to other technologies that are out there, and you said the terms multiple access, there's OFDM, and then there's OFDM-A, which is much more advanced in the scheduling systems for LTE that make most use of the resource blocks that are available to it. So it becomes much more efficient in comparison to other technologies, and OFDM radios are much more sophisticated than that of Wi-Fi chips that are available today. MIMO technology, if you've been doing wireless for a minute or two, you're probably fully aware of MIMO, so I won't spend too much time in there, but obviously it does have advantages, and particularly in the deployment of LTE, everything is pretty well standardized on using slant antennas versus regular horizontal vertical kind of antennas. They just overall perform a little bit better propagation characteristics, and certainly do much better over those who have tidal concerns if you're shooting across water that brings into a tidal effect. Peak data rate, you'll see here down at the bottom. So we have FDD and a TDD configuration. Long of it short, this is kind of the sales number that you'll see here. The downlink is 150 megabits per second in a category 4. Realistically, in that kind of channel, a 20 megahertz channel, you'll see The maximum capacity of an EOB on a 2x2 system is about 112 megabits. Anything more than that, if somebody's telling you it's going to do it in a 2x2, they're probably lying to you. So just look out. Uplink with that configuration system, if you're heavy downlink configuration, because you do have the ability to go from a heavy downlink frame to more of an uplink centric frame, and it's obviously at the cost of downlink. So if you want 112 megabits downlink, you're going to be allowed to have about 10.2 megabits on the uplink as far as capacity. If you want a little bit more uplink, you're going to be about 82 megabits on the downlink. You can get about 20 megabits on your uplink. So that's something that you can configure on a base station basis. However, it's one of those things due to GPS timing, you configure it on all of your base stations. You can't pick and choose one or two on a site and switch those timing mechanisms around. It does have an impact. We'll talk a little bit more about that. And this is kind of what I was just alluding to as far as speed. This is the graphical representation of it. So it's also known as subframe 1, and there's subframe 2. And you'll notice at the bottom under peak data rates, I have a 1-7 and a 2-7. So the 7 represents a special subframe in LTE, which basically helps push that speed. You can select between 5 and 7 right now, and we're going to be adding subframe 0, which gives you a little bit more distance capability, but at the cost of throughput. Everything's essentially a trade-off. So why LTE? That's one of my favorite questions I get a lot from a lot of people. Having come from what I'll call legacy WISP, where I had a mix of stuff. I started with some BreezeNet way back. Obviously, that graduated into the Alvarian. Did some Trango point to multipoint way back. And experienced the pains that came with that, and various other vendors throughout the way, obviously the Ubiquitys, Motorola's, Cambiums, etc. All of which have had their distinct advantages and disadvantages throughout the years. And LTE, when I got into this about 5-6 years ago, as an operator, I was expecting a lot of the same things, but better. Essentially is what it ends up being, and understanding the benefits of centralized provisioning. If a device fails, I just move the SIM card from one to the other. All the configuration is still there. Made installations go a lot quicker. There's a number of things that really that weighed into my decision to keep moving forward with LTE. Albeit said, I did have access to 120 megahertz of band 41 spectrum that I was paying for, but it did help grow the network significantly faster than it would have in other technologies. Why is that? Well, LTE is a global standard. There's a lot of money in R&D being spent every year by the big 4 carriers, and you can't even really call it the big 4 anymore. You can really call it the big 7. You have the AT&T, the Verizon, T-Mobile, Sprint, and now you got to watch out for the likes of Charter and Frontier. All of these operators are going to look at CBRS. Even American Tower and Crown Castle, they're all heavily invested in waiting to see what CBRS is going to do. And we'll talk a little bit more of that towards the end, but it's because of this mass amount of research and development that takes place in LTE by comparison to other technologies that we're able to really make it simpler, focus on what it needs to do versus what it has done in the past, in the sense of backwards compatibility. During the initial phases of LTE, there was a lot of concerns of 3G and LTE and making sure everything was compatible to a point. But now that we're really evolved into the later years of LTE, we can strip it down and make it a little bit simpler, a little bit more cost effective. And by doing all that, we'll be able to pass this stuff on to the end user. One of the things I like to use as a comparison from an overall capacity and coverage standpoint is if you have a lot of 900 systems out there today, I know many are looking at alternatives because 900 is becoming more and more crowded, is you can expect about 80% the same coverage of 900, but you can expect 20 to 30 times much more capacity than 900. So we have a number of users today. One recently replaced a 5-mile link, or 5.9-mile link that was 900. They were getting 3 or 4 megs, completely non-line of sight. Switched it to 365 Baicells with one of our 19.5 UEs, and they're pulling 60 meg. And that's something that is real. It lets that person finally, not that we necessarily want them always doing it, to stream YouTube, stream Netflix, get all that high quality stuff that they've been looking for a long time, that just will start to crumble some of the older networks. You know, Baicells, basing it just on LTE was kind of very strategic. One, it's standards based. That was one of our biggest things we wanted to focus on. A standards based equipment system and your customers actually become much more valuable by comparison to that of others. So we like to push people towards LTE because it does give your company a little bit more value than that of other equipment. And I can vouch that kind of firsthand. Whereas the first company I had sold for a certain dollar figure, and I know the value of my last company, the value of those customers was almost 2.5 times the amount, just because they were standard-based equipment. They're very easy technically to merge into other technical systems. However, billing systems is a whole other discussion. Those always seem to be a couple headaches involved. But from a technical perspective, migrating LTE to another LTE system is very, very simple. It's literally a CSV file, and you import it into somebody else's EPC, and off you go. So it's very handy in that sense as you continue to migrate, or if you decide to do some acquisitions, those who have LTE systems can be more valuable. What we made easy, I said we'd simplified the LTE system. We did. So we rewrote essentially the entire LTE stack with our system and reduced the amount of code nearly by 90%. So essentially, long of it short, is our founder, who is a very, very intelligent person, said, let's take what we've learned of LTE, let's figure out what we also went wrong in LTE in the very early days, and let's put in the good stuff. Let's get rid of all the stuff that's unnecessary, and let's simplify it, which is able to help us lower the cost of the processing power, bringing the power consumption down. Most radio heads out there for LTE draw well over 100 watts. On these types of systems, and we got our power draw to be about 30-35 watts, and that doesn't seem significant from a technical perspective, but it really is from an operator's perspective, because that's a real cost, is power consumption. And particularly the more sites you have, that's one thing that's often overlooked, is how much is it going to cost me in power to run some of these locations. And I can tell from purchasing some Alcatel-Lucent gear a few years ago that each one of the radio heads, and I needed 3 per site, had a drawing of about 540 watts per. And I had to have a baseband unit at the base of the tower to drew another 230 watts. That was a cost that I overlooked. I made the mistake on, and I had a power bill on that particular site well over $200 a month. Times that by all the sites, I severely underestimated my power consumption. So that is something to keep in mind when shopping around for LTE, is the kind of those little things that can creep up on you that add to the long-term cost. So power efficiency is one thing we take very, very seriously. We actually even make a product that's going to be announced soon called the solar cell. So we actually can power independently completely one of our 1-watt base stations with one solar panel. We have a lithium-ion battery pack that we sell with it, completely self-contained unit. Obviously based on the right amount of sun for your area, but averaging 4.5 hours of actual sun a day. That system can be self-contained, and it is perfect for deployment to help mitigate any need for utility power. With that said, there's a bunch of other factoids in and around it. So, by contrast, our competition continues to build in, linear progression, as we call it, bolting the new on top of the old and creating much more high complexity, and therefore complexity equals cost, because complexity also equals time. So all that kind of goes hand in hand, and we try to strip it down, and let's put in what we need to, not what we had to 8 years ago, 9 years, 12 years ago, etc. Baicells also, we provide an easy way to transition from existing Wi-Fi based networks to LTE. And the reason we do that was partially because of the CloudCore. The way we set up our systems for integrations now done by API, which is forever improving. I'm always pushing for more, because as an operator, I wear that hat often here at the office. And when talking with the research and development team, there's a lot of things that they overlook from a mobile perspective, but I bring to the table from other perspectives, actually being an operator, like, some basic functions like, hey, I want a signal graph to be recorded more than 6 hours. I like to have as much as a year look back at my signal, so I can, hey, this storm knocked out my signal, the leaves came out and knocked my signal out. I have something to reference. So it's little things like that we continue to improve on. Pricing. Baicells, I can tell you from firsthand experience as being an operator, this is one of the most cost-effective, if not the most cost-effective system out there, which is obviously lowering your CapEx. Because of the way our systems are designed and our low power consumption, it's actually lowering OpEx in many cases. And we work with some of the biggest operators globally, including some of the big four I mentioned earlier. And we also work with even the smallest operators. I think our smallest operator has 5 eNodeBs, and we enjoy working with them on a daily basis. Just got back from one actually on Monday. Baicells recently announced, for a lot of people who've had concerns, we're founded in China. We're founded in Beijing, which is where the world headquarters currently sits. But we recently announced a couple weeks ago, because of the demand that we have here in North America particularly, that we're relocating our world headquarters to Texas to meet the demand and growth of our customers. The North American entity has been really taking off, so we're actually changing the whole thing and bringing that here. And also, which I thought was interesting from my own perspective, is Baicells at the time, which I didn't realize until joining, was the only Chinese manufacturing company that I knew of that actually outsourced to an American assembly company. So we used a company called Jabil, that's who does all of our manufacturing. Granted, they have manufacturing facilities worldwide, but they're actually located in Boca, Florida. So that thought was very unique from our perspective. Usually you don't see that. Usually Foxconn gets just about everything, it seems. The leadership team here at Baicells is comprised of a lot of true pioneers of LTE. The founder of the company, Mr. Li Shin-soon, was one of the 12 fellows at Huawei. Very, very intelligent person. I'm very grateful to have got to meet him and speak with him several different times on my ideas and how I think this is going to grow the North American product line and help fixed wireless operators tackle that rural initiative that we often so struggle with. We also have great people here. Boone Senekim is our Vice President of Channel. Does a really good job working with companies like Winncom, making sure we get all the product to them when you need it, how you need it, and great support staff throughout the rest of the way from there on out. Baicells products are carrier grade. We have many carriers doing them today. In fact, 24% market share of all small cells at China Mobile are done with Baicells, which compares to hundreds of thousands of eNodeBs. And of course, we're standards-based, which is, that is LTE. Yes, obviously we do benefit from lower cost production costs and improved supply chain, but then again, because we do, so do you. So it works out pretty well. And as always, we didn't invent all the business models within LTE, like from fixed wireless small cells. IoT's certainly coming. We're seeing that more and more every day, but we do invent the technologies and features that make these things much more viable into your budgets, particularly. Adding Baicells and eNodeB and user equipment, it's pretty straightforward. It extends your network into locations that normally you wouldn't be able to get into. We've even released products such as our Nova 227, which I'll review shortly, just kind of a micro pop integrated PoE plus powered LTE small cell. Works on a number of different PoE plus switches very, very easily. I haven't tested them all, but we certainly tested a lot of the common ones, and they perform very well for a small pocket, trying to keep a standards-based system up and going without having to deviate off that line too much. We certainly design them. We want easily plug and play. It's everything. Everybody always says that in the sales field. It's more like plug and pray, and we'll see how it works out. But it is pretty simple. What we tell a lot of people, particularly me, since I conduct most of the trainings, is you can expect. Oops, the wrong button there. About an hour to hour and a half for your very first configuration, because you're going to run into challenges. I'm not going to say you're not going to, but therefore after, if it takes you longer than 15 minutes to get something going, call us. You're doing something wrong, plain and simple. We want to help you get this going quickly. We don't want you wasting your time. Connecting more or less, this is kind of one of our slogans. We also see in the bottom left-hand corner of our slide deck, LTE, easy as Wi-Fi. Now, I don't want that to be a conception of like you're going to, pop in a ubiquity radio somewhere and it's just going to be a couple things and off you go. That's not the way it is. LTE is very, very complicated. we are doing our best to make it appear as easy as Wi-Fi, and we do that with things like a web GUI configuration, where typically it's all CLI, or tens of thousands of lines of XML that needs to be uploaded into macro base stations, and many other steps that we have eliminated. So we say LTE is easy as Wi-Fi because we have taken what all the burdens were of cellular configuration and mobile base station configuration and simplified that down to really 2 or 3 pages, sometimes 4 if you really want to start playing with some advanced settings. Web GUI that is very easy to comprehend, and quick to configure. I talked about this a little bit earlier. It was green. Our eNodeBs are smaller in size, require much less power consumption, which means less carbon emissions, a healthier environment. Of course, that's more of a sales pitch, but those are also real things, and they also have a cost by being less power consumption, as I mentioned earlier. So it's something you never want to overlook, is how much that power consumption can really eat up at your bottom line. Affordable. We certainly dream of a world where connection is accessible to everyone. And get rid of some of that expensive and complicated wireless networks, and we're getting there. More and more you're seeing new initiatives. Verizon recently announced with Samsung about their Open RAN initiative, which I thought was kind of fun and interesting, because we've been working on that for the last 2 years. Open RAN is something we believe in a lot, and I'll talk a little bit more about that. But essentially, think of the common open networks that you see a lot more from various stimulus projects, open fiber access networks. It all sounds good, but we're really putting the driving force behind actually Open RAN. So we'll provide you an eNodeB. We don't care if you go buy somebody else's EPC, or if we can even make it an RRU, and you could go buy what they call a BBU, or a baseband unit, and synchronize all that together in all big net kind of system. And I'll explain more about that as well. But we thought that was a very interesting play on Verizon and Samsung's part, and we're kind of like, well, you're 2 years behind us, but see if you can catch up. Just here in North America, we have over 450 commercial deployments. We have 25 different products plus. I think the number is probably closer to 35 plus now at this point. 7 offices worldwide, over 300 patents, which I think is closer to 325 now, and nearly 400 employees. My favorite number of all this is we are 75% or better R&D, which almost hurts us at times because we don't have that many salespeople by comparison, but we have a lot of great support when we have certain problems fixed. Sometimes it's not as fast as I'd like it to be, but I do know that they are working on it, and I can get an update at any time. So if you are having a problem, we have some customers occasionally do, that gets escalated very, very quickly should we not be able to figure it out here, and we get the rest of our R&D team specific to that product line immediately involved, and they'll help troubleshoot that problem, obviously capturing various logs and things like that. Our small cell series, essentially everything that we do, we're a small cells company. That is our focus overall, and that's what we put all of our eggs into, per se. The fancy word, everybody's been hearing the term 5G. 5G is this fancy way of saying, hey, we're going to put a lot more base stations in, and they need to be a lot closer to the customers. That's how we can get the speed up. Anything other than that, it's really just a bunch of fluff for the technology. Obviously, we're waiting for the final approval for the 5G standard. I've had the ability to work on various different 5G stuff. I know we have a 5G roadmap that we'll be announcing in the next couple months, and what our plans are and how we intend to tackle that, and a timeline for it. It is something that we're putting a lot into, and you actually get to see over here in the far left the Nova 4x10 watt. Of course, this is more for band 41 operators in the US, and we'll have a 10 watt functionality, use it for CBRS in Canada, or that band for band 42, 43. That will be kind of the staple towards our 5G plans, as well as some other ones in the future. Don't mind those bands that you see down below, the 457, 1.4, etc. Essentially every one of our products, and we do in various markets, are developed for any LTE band. We actually make products in all of them. We're not limited to just band 41 or CBRS. We make a lot with band 1, band 5, band 12. We have a lot of different products in all different scales of products going across the board. You can see here, these are obviously overestimations, but we do try to cover ourselves naturally. Like it says, for example, this one over here on the left covers 260 watts. That's a lot of juice. It does not. It's significantly less than that, but we're still in development of this particular product, so final numbers will be reviewed. And even so much so, I'm kind of slacking on the far right. The Nova 2x1 says 50 watts, but in reality, it's about 33 watts. So it's significantly more efficient than I have on this slide deck. And our current product that you see out here is a Nova 2x10 watt, also known as a Nova 243. So it's got two 10-watt ports. It's very heavily used up in the Canadian markets for band 42, 43, and we have a band 41 production product of this as well here in America. This says 190 watts. It's closer to 100 watts. It's significantly less power than that. And our newest small cell to the family is the Nova 4x1, known as the Nova 436. This is our first carrier aggregation radio. And I'll talk a little bit more about carrier aggregation after I review the rest of these products, but is one of my favorite features of LTE. These are some other ones that we do more globally than anywhere else. The Spectra is a recently FCC approved. It's actually LTEU, so this is a 5.8 gigahertz system over here on the left. It actually does 5.8 gigahertz downlink and 5.1 gigahertz uplink. Currently supports up to 32 active users with a maximum capacity of about 150 megabits down and 75 megabits up, each on a 20 megahertz channel. And of course, that's dedicated. So you have one 20 megahertz channel dedicated for downlink and another 20 megahertz channel dedicated for uplink. Now, our Neutrino, that's a really small cell. Essentially, it's only 125 milliwatts. Usually designed for, not usually, it certainly is designed for indoor applications. We have a lot of that overseas. Nutricell is one of my favorite new ones. This is also 125 milliwatt indoor, but it has a built-in Wi-Fi module. And it has 3 different modules that can be popped in at any time or removed or switched of various LTE bands. So you can do a CBRS band, you can do a band 41. Again, this is for an indoor application. I'm pushing to have one of these made for outdoor as well, where it's modular based. I think that's just one of the coolest things out there. And of course, it's PoE powered in this case. The L-Cell, or L-Cell 2 rather, this is a really cool product. It's heavily used indoor overseas. So this actually has a power line connection, as obviously and power. So it has its data and backhaul in the single plug. This is really good for buildings, indoor applications, for example, that just have very poor data cables, which is often found overseas in various countries where the data cabling is in pretty rough shape. So in this case, they can outfit an entire building with broadband or mobile services very, very quickly by plugging these into outlets throughout. They automatically backhaul into their telecommunications connection point, and they'll be able to go out from there. The Solo Cube is a pretty new one. Don't have a whole lot of these out there yet. This is mostly a prototype, but this is essentially a 4x4x4 small cell. It's very small, 2x50 milliwatts. Desktop application, you're trying to fill in an office space, PoE powered, etc. Then we have, of course, the world's smallest small cell, until, of course, we made a new one, the L-Cell. This is essentially this version of the L-Cell 2 without the PLC. So it's a very low power small cell, supports a very small amount of users. You can see 16 active, which is different than connected. We'll talk about that as well. Here's some of our fixed wireless CPE or UE, both in Cat 4 and Cat 6. We have the Atom 6.5 on the left, which is an indoor 6.5 dBi gain for band 48, which is a CBRS band, or band 42, 43. We have the Atom 14, which is also a Cat 4, Cat 6 radio. We have then the Atom 19.5. So the Atom 19.5 is very unique because that's one of industry best gains for this band. It's 19.5 dB for the CBRS band, mostly right in the middle of that band. So it's a very high performing UE for the particular band that we are in. One unique feature we have with the 2 outdoor radios, we actually have what they call the MIU, the Management Interface Unit. So it's a Wi-Fi chip built into every one of our radios, very low power, only 50 milliwatts, that allows for an operator or an installer rather to connect with their phone and actually log in and see the signal screen. So you don't have to go be hardwired or anything like that. The SSID and the WPA key are printed on the side of it. It's only on for a few minutes. Little caveat though, the software is not on the subscriber radios yet. That's coming in a few weeks basically. Then you'll be able to have access to that, change it, and any other configurations. However, it is not designed for home network resolution in the sense of trying to service the whole home with that little 50 milliwatt radio. Do not do that. So before I move on to the next set, so the real big difference between Cat 4 and Cat 6 is essentially speed and performance. Is Cat 4 is a single carrier UE, and Cat 6 supports dual carrier. So I mentioned a little bit earlier about dual carrier. That's long of it short means that you can take two 20 megahertz channels instead of creating 140, which causes you to have 3 dB of signal loss. By doubling the channel size, you can aggregate two 20s to appear as a 40, and they can be in different parts of the band, which is extremely helpful. So you can get 40 megahertz performance at a 20 megahertz coverage, which is one of the coolest things about LTE. So you do not have to sacrifice your receiver sensitivity in favor of coverage. Very positive change there. So Cat 6 is required if you want to take advantage of carrier aggregation, which is bonding the two channels. However, a Cat 4 device will work on a carrier aggregated E node B. It just won't be able to take both channels. It'll just take one of them. So that is very handy as well. Kind of the million-dollar question: how does LTE solve non-line of sight challenges? Like I mentioned earlier, the certain the unlicensed bands were limited to a number of different challenges. We do get to put out a little bit more power in the NN license and soon to be CBRS band that allows us to get through a little bit more trees. And of course, 3.5 certainly propagates better than a lot of 5 gigahertz platforms. That kind of goes without saying. But you do also get about 7 dB advantage over Wi-Fi. We have a significant better receiver sensitivity. So for example, a lot of people won't do a connection at negative 80 RSSI. Well, negative 80 RSSI and LTE is about a negative 109 RSRP, and LTE maybe in 110. That will pull 60, 70 megabit all day long. But in RSSI, that's still negative 80. Most systems will just break. They won't even make an attempt to attach because there's too much noise floors in the trash can. It's not going to work very, very well. So that is something that you get as a distinct advantage over an LTE chipset by comparison to a Wi-Fi chip. It's just that much significant stronger receiver sensitivity. So LTE, because of that receiver sensitivity, improves your non-line of sight ability to get through another set of trees that maybe you couldn't get to push just a little bit further than you ever could have before. However, we're still limited because it's in the 3 gigahertz space. If you're particularly looking at that product, if you have band 41 licensing, you can push even further. 6, 7 miles through trees is not uncommon with 60, 70 megabit performance, depending on the carrier aggregation configuration of that system. Most of the mobile operators have all upgraded their LTE networks, all their networks completely to LTE. There's still a handful in the very rural areas that are, using 3G or even 2G technologies, but everybody has been unifying on this standard, which has made things much, much easier, and it helps us get further and faster into these areas that we haven't been able to before. Though this is kind of a marketing thing at the end here, Baicells has made LTE as easy as Wi-Fi. We have taken the complications of LTE, we have certainly simplified it. I don't want to oversimplify and say it's that easy, but it is quite simple to get introduced to LTE, particularly with Baicells. LTE will dominate the CBRS band. There's no question about that. Every carrier, you guys have probably been following various threads and communications and WISPA, if you're a part of that there's a ton of that's going to be happening with CBRS, and everybody's just waiting. So that will kind of be a good segue into my CBRS discussion here shortly. Here's some of the use cases we have. This particular one has 10 subscribers on it. This is varying distances, some at over 4 miles, and what we expect to see. So we're seeing about 60 megabits per link. Some customer sites. Here's the coverage of what we've got going on. Obviously, some of this is non-line of sight, some of it is line of sight, but it's a good mix of both in this case. Here's another gentleman for us up in Illinois. He's got a number of different systems out there. Very good solid network, MPLS built. It's great backplane, good backhaul, things like that. And this is what he's replaced. He's replaced some canopy with some Baicells, and just the difference of the 1.5 megabits down here, or to never, I should say, depending on how good that connection was. All of a sudden, we're pulling 46 megabits on the same exact path profile. So you can see down there, it's a perfect example. So swapped it over, bam, 40 meg, 2.85, and clearly no line of sight. So Rick Harnish, our director of WISP Markets, usually does the CBRS stuff, but I've been heavily involved with it, and he happens to be, if you're following us on our Facebook page, he's on a little road trip across the Midwest and stopping into various operators on the way, so I'm filling in for him on this particular section. Why should you care about CBRS? Well, most of you, if you're looking at it, you should be. The very cool part right away is we're going to expand from 3650 and then 3700 that we have today, is we're going to get another 30 megahertz immediately towards the bottom there. So we'll have 3620 to 3700, which will be what's called GAA, or General Authorized Access. That gives us, obviously, quick math, 30 more megahertz to play with. We'll soon have the ability to bid on other 70 megahertz available. And the big thing that we're waiting on now is not so much what the allocation is going to look like, is when are the auctions going to start and how much territory do they cover? Are they going to cover counties? Are they going to cover geographic serving areas? There's a bunch of different stuff that is up for discussion still. And essentially, we're just hurry up and waiting for the FCC to tell us what the plan is going to be when it gets voted on. But we are very, very confident that we're at least going to get 30 more megahertz of GAA spectrum, and that will certainly help networks grow. So it gives you 80 megahertz of this particular band to play with. LTV has been developed and driving investment for network expansion. You know, a lot of 3650 to 3700 has been sitting on WiMAX for a long time, and of course that has its limitations. And you know, now based on the rules that exist, that those networks are going to have to be retired by 2020, or April 17th, I think, 2020, which I'll show a little bit later. So you need to upgrade anyway. You need to get standardized on different equipment that is CBRS compliant, works with the SAS database, etc. This is what it looks like as it sits right now, the way the rules are. We don't expect much of a change in the way the frequencies are laid out. So the priority access license, otherwise known as PALs, those will be auctioned off, but not one person or one entity can buy more than 4 of those channels in 10 megahertz blocks. So that means if 70 megahertz available, Verizon couldn't come in and buy 70 megahertz. They could buy 40, and somebody else could buy the other 30, but everybody will have a fair shot to bid that particular service area. It's just the service areas are yet to be defined. A little bit more of what I was talking about earlier. Yeah, so this is what we're looking for right now. So there's been a 5-year transition period to CBRS rules, but that's coming right up. It started in 2015. Licensee holders can continue to register locations, however, they are not protected. So you don't have the same rules that you had if you started deploying these a couple of years ago. We are expecting maximum power level to increase in rural areas. Right now, the maximum EIRP is 43 dBm. We're expecting to go as high as 47 dBm EIRP under CBRS rules in rural areas. Yeah, so April 17th, 2020, if you're running a lot of WiMAX systems today, that's essentially your deadline to switch over to other systems that are compatible with the CBRS rules and the SAS database. Registration for the base stations must have been on file before that date shown, in order to have interference protection in the meantime until that date. If your license expires before, you can get a renewal only until April 17, 2020. So if you have an NN license today and it happens to be coming up for expiration, you can renew it, but it only is going to be expanded until the 2020 timeline. License granted after April 20th, 2010 get their full 10 years, so that is a small exception, but there's not many. Users will be post-transition, users will be GAA, but no PALs in band. Grandfather license will receive interference protection from GAA users within the protection law, so long as they were in use by the date above. And you must have registered all your customer locations, all your base station locations, and certainly in compliance with the FCC rules. Registrations approved after 2015 are not entitled to interference protection. During the other times, you are treated as an incumbent user during the transition period, so you are protected prior to that. All right, so any questions on the CBRS stuff, I strongly encourage. So Steve Coran put a lot of this information together. For those who don't know, he's the Wireless Internet Service Provider Association attorney. We contract him an awful lot to join us on various webinars and trainings, etc. Rick Harnish works pretty closely with him, so this is his email. Should you want to get more information on CBRS and arrange a phone call, please do reach out to him. He knows a hell of a lot more about it than I do, but nonetheless, it's a very good thing that's happening right now. Big question I get often is, when do I expect the GIA to be available? I'm thinking it's going to be about fourth quarter this year to get access to that additional 30 megahertz. Then the licensing for our auction, I expect the first quarter of 2018 or 2019 rather, so we can start bidding on some of these spectrum assets. So HaloB is kind of the wrap up of the webinar, and what this really is, it's a distributed EPC solution. So for those that get a little weary about the cloud, which there's always some, and I completely understand, having lived on both sides of it, why you may be. HaloB is a feature add-on to an eNodeB at a cost. I think it's $250 per eNodeB if you buy one, or $199 if you buy a 10-pack, something along those lines. That allows you to disconnect, no pun intended, from the cloud and be completely independently operating without the need for a cloud EPC. So what it essentially does, if you recall the diagram earlier on, is and obviously on the screen today, is it will take out the need for any backhaul concerns that you may have. You may have, if you have a weak uplink from your uplink provider and it has problems talking to Microsoft Azure, which is where our cloud is, that would take that variable out of the mix, and you wouldn't have to worry about that anymore. Because packet loss and LTE, particularly if you have the EPC somewhere other than the on-site, whether you have poor microwave backhaul, you had a fiber get cut, any of those variables, uplink the internet, etc. with poor, you're going to lose all the clients association off that particular eNodeB. So HaloB eliminates that. HaloB allows all that connections to stay connected, because once they have made their initial connection, the HaloB system connects to the cloud only for authentication. So once it adds that authentication, and it will never have to go for that authentication again. That authentication will be stored indefinitely in the eNodeB and prevent you from having to go out and use the cloud again. We do also offer the OMC system, which is what that authentication program is, that sits in the cloud today. That's actually a standalone product that can be bought, and you can put it on your own cloud or your own VM system on your own physical network, and you can be completely 100% independent from the cloud connection. Centralized EPC, like I mentioned earlier, they're very, very expensive, and this is what this kind of diagram on the left references to, or on the right rather, is you have the S gateway, P gateway, internet. Well, if you lose the backhaul on any one of those, you lose all of your sites. If you ever lose that EPC, everything goes down. With distributed EPC, every tower, every sector of that tower is considered its own EPC. So if you lose one, you just lose the one. You don't have to worry about recovering every particular site. It's kind of the old, if you lose a Wi-Fi AP, you lose a Wi-Fi AP, you go replace it. But you didn't lose the entire network because of it. This is kind of what it looks like. Again, once you confirm over to HaloB, so we have the every site, it's its own Halo. So it's kind of a play on eNodeB. We called it HaloB, all one and the same. Essentially, I said it's just part of the distributed EPC model. Highlights of it. So the NAS is processed by the HaloB, and the UE will always be online. Online users under that HaloB will be affected. Only users under that HaloB will be affected when there's a failure that occurs. So if you actually have one fail, only those users are affected. However, if they can hear another cell and that other eNodeB has that information preloaded, they will automatically move over should they be able to connect and hear it. Albeit probably a weaker signal, they'll be able to connect it. Less investment. So if you were looking at a centralized EPC, which like I said can cost from a few thousands to all over $1 million, this is significantly less expensive, as I mentioned earlier. By just a couple $100, you can get that feature key to unlock that system. Self-configuration, plug and play, shorter TTM, etc. So everything is a little bit quicker because it decouples that eNode B and the core network. It's going to work for it to provide layer 2 over LTE, which is not common. Layer 2, IPs and things like that are not typically part, or not, let me rephrase that, they're just not part of LTE. Every vendor kind of has their way of dealing with it. Some do VPLS. We're going to be doing it with VXLAN, and that's how we're going to build a VXLAN server into every eNode B to provide a layer 2 function. We'll be able to support multiple APNs, so that will allow for either private APN services, not only just for commercial use. If you want to provide private network across your infrastructure, you also have management IP information on your eNode Bs and LTE network, which is not typically common for those running single APN networks. I think essentially everything appears as a big flat network. But in this case, we'll be able to isolate management from service. This is what the diagram looks like with the HaloB system. You see the local breakout up there, and the only time we have is in the APN1 management interface. That goes up to the cloud to get its information, such as PLMN, the EAR FCN, which is essentially frequency in LTE, the bandwidth, which is channel width. So it's a 10s, a 15s, a 20 megahertz wide. All that information is informed by the OMC system. And all the subscriber information synchronization, that happens in BOSS. That's where the SIM card gets provisioned. You set your speeds, but once it downloads it into the HaloB, it has it. The HaloB does continue to talk to the BOSS, only looking for any changes to that plan. Should there not be any, it doesn't do anything. So that'll phone home from time to time to make those changes, whether that be in the cloud or you end up buying the system to have locally on your network. It'll phone home to there. So both options exist. How to get it? New hardware comes with, you can get it with a license. Software upgrade all of our existing equipment. So if you see equipment out there today, they're all compatible with HaloB. And it just requires you to reach out to your distributor, in this case Winncom. They'll ask for your serial number. They'll submit a request to us. We'll then in turn provide a key back within 2 to 3 business days. So that's it from my presentation perspective. I certainly expect there to be a couple questions or scenarios. Feel free to stick them in the chat box. I'm happy to answer them and discuss a little bit more about LTE, either HaloB, different features, why you're looking at it. Do you have LTE today? You're looking at expanding your other vendors to see if some work better than others. All these scenarios I've dealt with quite frequently, so feel free to ask some questions. Well, let's see the questions. Okay, here we go. Okay, got some good questions here. Give me 1 second while I get them organized. Will you be able to get the slide deck from today? I will share that with the Winncom team, and you'll be able to have access to that slide deck. I also believe this session is being recorded, and it will be available on their site. What is the license scheme that Baicells offers? I am anti-licensing as they come. We do not have a licensing-based model other than HaloB. That's the one-time license upgrade for that particular eNode B. And in fact, so much so because I disliked it, we even allow you, in case of a device failure, to transfer that license to another ENB one time. Does Baicells have engineering tools for planning? Yes, we do. So we actually offer free planning for terrain only here in the US, so the lower 48 to be exact. So we can do terrain-based designs, and I will tell you, it is very optimistic. We can do, at a cost, work with your distribution team. They'll work with us. We can provide quotes for clutter data, and we can get clutter in some markets as accurate as 1 meter to as more inaccurate, like 30-meter clutter data. and we can provide some designs based off of that. What release of LTE is supported? So right now, our most advanced system is LTE release 12, and another one that's up and coming is we're actually working on a 5G release. So that one will be significantly more advanced, but that'll be flirting with the LTE release 14, 15 initially, and software upgradables into 5G. Most of our 1 watt products, other than the 436, which is the release 12, the Nova 233 and the Nova 227 is a release 9 product. It's a single carrier, very simple product. How does Baicells work in a layer 2 network environment? So we will be introducing VXLAN support into all of our subscribers, which is being tested today, and we'll soon be adding it to the HaloB function, which is something you will need unless you run your own VXLAN server. So if you run a VXLAN server at your head end, you will be able to have a VXLAN connection from the subscriber radio all the way back to that and provide layer 2 functionality. Great questions. Is LTE and 5 gigahertz a viable solution for you guys in the future? I have mixed feelings about that. We do have this product. I think depending on what the application is, I think would depend on my answer. In most cases, it's just another 5 gigahertz product with my initial reaction. I'll be completely honest there. So I do think it has a use case, particularly the part where it's going to be software selectable between both TDD and FDD. But this is the really cool one that we're working on. So we're definitely working on this 5 gigahertz LAA system that we'll hopefully have available come October to formally announce. But it has as much as a 1.7 gigabits downlink capacity. It has a 4x4 4-chain downlink only and 5 gig, and it uplinks at 3 gig. So that is a really cool and special product that we're developing right now that hopefully will be ready come Wispalooza. Another product that includes 5 gigahertz are all products currently 2x2. Yes, all of our products are currently 2x2, but as I mentioned just a moment ago, we are building in some 4x MIMO stuff. Another question, I see a side-by-side of Baicells versus 900 megahertz canopy. Is there one available for 900 Baicells versus Cambium PMP 450i? We probably have a bunch. If you are not or haven't joined, if you look for the Baicells operator support group on Facebook, we have almost 1,300 people on that group that will share different user experiences, and 450i is certainly one of them. So by all means, check into it. We have replaced a lot of 450 with LTE, and we have some people where the 450 does work a little bit better because again, it does go. It's 900, so all depends on the application and of course the noise. Noise is the biggest challenge there. Are the 900 megahertz canopy numbers for the old FS1 series or from the newer 450? That I'm pretty sure it was the old FS1 to, you guys obviously had a similar question at almost actually the same exact time. What would be a good test setup to try LTE? Work with your distributor. We have a number of different special promotions that go on for people that are looking to get into LTE. Depending on what your application is, the 1 watt radio is kind of our go-to. The Nova 227 is a little bit better to get into initially because it has a built-in 65-degree antenna. It is lower power though, so therefore lower range. So its overall EIRP is only 40 dBm, whereas you're allowed a maximum of 43. So in fancy words, it means you can go up to 10 watts versus 20 watts. Currently, we have a successful 5 gigahertz 2.4 and limited 900 in our environment. I don't know if that's a question or a statement. Public IP on a customer router, UE in bridge mode. So that's something I addressed earlier. So in order to do customer IP on the public router, that would require something like VXLAN, as I mentioned earlier. Anything special regarding new Gen 2 CPEs and reading the SIM card? We were able to read the Baicells SIMs with no issues. We're unable to read our self-burn SIMs. No, nothing particularly special about the new CPEs when it comes to reading the SIM cards. If you're having a hard time reading your self-burn SIMs, I'm going to say there's probably something wrong with the burn settings. I've burned tens of thousands of SIMs, not necessarily just for Baicells, but for others. using various PLMNs with great success. So if you're having a problem, by all means, see if you can get in touch with me afterwards. My email is cameron.kilton@baicells.com, and I'm happy to help you out. Oh, skipped a couple of questions here. Is the VX Layer 2 scenario still not commercially available? Would it be necessary for operators that want to keep their PPOE user scenario? Yes, it would be. However, I would encourage you to look beyond your typical PPOE scenario. It's adding a lot of unnecessary overhead to the LTE stack already. LTE essentially is its own PPOE end-to-end service because it creates what they call a GPRS tunnel and a bearer between a user's connection all the way back through to the serving gateway and packet gateway. So it's unnecessary overhead. So if you're using PPPoE now, I understand. I have a number of networks. I was personally a PPPoE user when jumped into LTE, but I had to look at different ways of doing that and authenticating my SIM cards. And I did so with my billing program and an API call. That set the package speeds, that did all the automated shutoffs, etc. And it was very efficient. And just like PPPoE, it's one-to-one IPs. You don't lose any IPs for routing and all that fun stuff. Hi, Cameron. As a basic cost per sub, how would you compare cost of the Baicells solution to traditional LTE solution? Traditional LTE solutions, I would say, depending what you mean by traditional. If you're saying, hey, how much is this going to be in comparison to a Nokia installation? I'm going to say you're going to be laughing yourself all the way to the bank if you save a bunch of money. But if you're comparing to similar technologies, and even the Telrads and the Airspans, which are a little bit less expensive by comparison to some of those bigger guys, we're still going to save you a certain amount of money. But everything, I don't want to give essentially business advice, but if I was you, I would be taking all of your costs included. That'd be OpEx, your CapEx, how many customers your goal is per sector, and break that down to what your ROI needs to be to fit your model. So that's really a big question. I don't want to try to oversimplify it, but you gotta really dig into what works for your case, what your your average revenue per user wants to be, all that fun stuff. So I mentioned that GAA should be available in Q4 2018. Does that mean an NN license for 3.6 gigs will no longer be necessary at that point? Yes and no. You will not be protected if you don't have a 365 license. So you are protected to 2020 under the existing license that you have, or if you go out and acquire a license, you will have the ability to operate under different rules than in comparison to the CBRS rules. The difference with CBRS rules, we have to use a SAS database. That SAS database is not done by us. It's done by a company called Federated Wireless, is one we're working with, and we're also working with Google. Pricing on that is, they charge a fee per month for every base station, every customer connection for that SAS system. So you get a slight advantage if you have a 365. You don't have to necessarily pay right away, but you don't get access to as much spectrum. So it's a trade-off. So pricing on that's really still be to determine. We're negotiating with those different SaaS providers today to make sure that we can get the best rate to the end user, and that would be a pass-through cost. We don't mark that any of that nonsense up. Can you see the UE's RSRP, RSSI, RSQ accepted parameters? Yes, all of that actually. So we'll show you both RSR, well, not both. We'll show you all RSRP, RSSI, SINR, CINR, RSRQ, and various other parameters throughout there. How would I compare non-line of sight penetration between a PMP 450i 365 gigahertz to a Baicells and 10 watt, pretty much OFDM versus OMDA? I would expect you to have better channel utilization because of the OFDMA. That's where your significant advantage is going to be. So your overall capacity should be greater with the OFDMA solution versus that of the OFDM. What kind of lightning protection do you offer, and does it actually work? Well, that's a great question. If it's a direct hit, it doesn't matter what I give you. With that said, anything from a lightning perspective standpoint, it's just all about good grounding. I don't recommend anything better than that, and our manuals will point out a lot of that. We don't recommend anything less than a 6 gauge cable for grounding. And we want make sure that's obviously has less than 4 ohms resistance or whatever the magical number is. A lot of people follow the R56 guidebook for Motorola for essentially everything grounding. If you do that, you're not going to be in a bad situation. From a coax perspective, anything under 6 foot or 2 meters of coax, I don't recommend putting surge arresters in. They actually cause problems with LTE, and you'll be hard pressed to find anybody that's deploying LTE at the carrier level using surge arresters. They often just cause problems with the signals and all that fun stuff. But if you're properly grounding your antennas, you're properly grounding the sheath of your cables and all that, you will be in very good shape. We do operate at both -48 and +48 on the system. We utilize a floating ground in the chassis, so we do have a really good grounding mechanism in that sense to get rid of any static, assuming the units have been properly grounded. So if you follow good grounding practices, you'll be in good shape. But I'm not going to lie to you and say a direct lightning hit, you're going to be fine. You're going to have a bad day. Will your products work with Visp.net for auth and speed? So Visp has been provided our API. I don't believe they have finished the integration yet, but they are working on it. So keep pushing them, and they should have the API set up to work with our system. Also, it shows both RSRP1 and RSRP2. This aims the antenna left, right versus up and down. So we do show both RSRP readings, basically for each chain of the system. So we do have that. Any other questions? That's it. It looks like I covered all those questions. I'm sure there's more. If you do have some afterwards, you certainly can get with Winncom, and they'll reach out to us, and we'll get back to you right away. Again, my email address, albeit it may be a little bit of time before I get back to you. There's usually a flood of them after these. Is Cameron.Kilton@Baicells.com, and I'm happy to individually sit down and have calls with you all as we continue to get you interested in LTE, or at least interested in Baicells if you're already doing LTE. There's various different use cases that come into play, and I'll certainly give you my honest opinion either way, and which way I think you should head with that. In the meantime, I appreciate you all joining today and listening to me for the last hour and a few minutes, and look forward to having an opportunity to work with you guys in the future.
Cameron, thanks for your time, and everyone that's on the line, thank you for joining us today. Have a great day. Take care. Bye-bye.